All right. Okay, so we are looking at our rule number 6. Okay, and please take note. Okay, my rule 1 could be somebody's rule 2, whatever. So the rules are not in that order, are not strictly in that order. So please take note. So that's the more reason why when you are presenting your solution, okay, you don't write rule 1. Okay, you don't write rule 2. Okay, you have to just apply the rules. Don't give the rules what names when you are applying it, because the rule 1 could be, just as I said, somebody's rule 3, what have you. So now let's look at if I have any a, okay, to a negative exponent. So you can see that so far all our exponents are positive, but your exponent can be negative as well. So a situation where your exponent is negative, okay, what will this give us? It's something that you know. Anytime you see a negative exponent, very good one. You started well.
Over
So
A
over A,
raised to the power M.
raise the power M. Very good. Okay, so this will be the rule for the negative or exponent. So take note. So example, if I have 3, okay, to the power minus 4, this is equal to 1 over 3 to the power 4. So in indices, okay, you avoid concluding with a negative exponent. So if you have to avoid concluding with a negative exponent, then you should know this rule. So that if maybe you added, assuming maybe the addition 1, I had, okay, or let me even do the subtraction 1. I have maybe 2 cubed minus, or divided by, let's say 2 to the power 6. I know that this will give me 2. Okay, I need to subtract the exponent, so it will be 3 minus 6, which will give me minus 3. I can't conclude with this because I have to avoid concluding with a negative exponent. And with this, if I don't know this rule, there is no way I can avoid concluding with a negative exponent. So this should tell me that my next step, I should have 1 over 2 cubed. Is my point well made?
Yes, please.
Okay, so that will be it for rule 6. Now, we are going to look at another rule, rule 7. Okay, and rule 7, this is what we are going to do. Okay, I have 2 numbers, A and B, multiplying all of them to a certain power. So far, we looked at only one number to a certain power, only one factor to a certain power. But now we are looking at 2 numbers, and we are talking about 2 distinct numbers. Okay, so here A is not equal to B. So take note. So whenever I have this situation, okay, what do I get? Again, this is not something new to you. So help me. So this will be equal to, hello, I'm waiting.
A raised to the power
A raised to the power
M,
M times B raised to the power M.
okay, times B to the power M. Very good. As simple as that. So example, okay, if I have 2 times maybe 3, all to the power 4, this will be equal to 2 to the power 4 times 3 to the power 4. Point well made.
Yes, please.
Okay, now 8. Okay, this time round, my numbers that I multiplied, I am going to look at them as what? As division or quotient. So I will look at A over B, also to the power of M. So what will this be equal to? Your numerator to the power M over your denominator also to the power M. Is that not it?
Yes, please. Yes, please.
Okay, so example, okay, I'm going to change this. If I have 2 over 3 all to the power 4, this will give me 2 to the power 4 over 3 to the power 4. Point well made.
Yes, please.
And the last but not the least rule. Okay, this is what we are going to talk about. My A over B, this time round, it is raised to the power a negative exponent. Okay, so we know that this will give us, this is what we are supposed to do. Okay, this will give us, anytime you see a fraction, okay, to a negative exponent, invert the fraction, then change the exponent to positive. Should I come again, or my point is well made?
Please, your point is well made.
Okay, so I will invert the fraction, so that will give me B over A. Immediately I invert the fraction, the exponent here becomes positive, so positive M. Okay, so this one now becomes similar to what we just did here. So it will be B to the power M over A to the power M. Is that clear?
Yes, please.
Okay, so example, if I have 2 over 3 all to the power minus, okay, 4. Okay, I will say that this will be equal to 3 over 2 all to the power 4, which in effect will give me 3 to the power 4 over 2 to the power 4. Point well made.
Yes, please.
And basically, this is coming from this fact. Okay, what we have here is coming from this. If I have A to the power over B all to the power minus M, okay, I can use this same definition. It will be A to the power minus M all over B to the power minus M. Do you agree?
Yes, please.
Yes, please.
However, remember, we said you have to avoid concluding with what? A negative exponent. So I know from here that my numerator now is 1 over A to the power M. And my denominator will also be what? 1 over B to the power M. Do you agree?
Yes, please.
Okay, good. All right. So it's like indirectly we are proving, okay, this result. So if you're asked to prove, this is what you are supposed to do. So now I can say that this is equal to what? My 1 over A to the power M, then divided by 1 over, which will be times what? B to the power M over 1. Is that not it?
Yes, please.
Which then becomes B to the power M over A to the power M, which is exactly what we have here. So this is the proof of this particular rule. Is that clear?
Yes, please.
Yes,
Very
please.
aside these rules, okay, you should know certain properties. So I will capture this one and send it to you. Properties of indices. I think that one you know. Any number to the power 0 is what?
1.
1. Okay, any number to the power 1 is what?
The number itself.
The number itself. So these are the two properties of indices that you should know. Okay, as simple as that. Okay, so I can choose not to write it. Is that not it? You know.
Yes, please.
Okay, good. So now, okay, I'm going to capture this one and send it to you. Okay, after that, we'll come and look at a typical indices question. It's not always that you see a question involving only product, only quotient. Okay, it can be a mixture of all the rules. Okay, so we'll be looking at that right, okay, after putting this picture on the platform. So let me pause and do that. Okay, so as you can see on the board, we have our first set of questions, okay, on the indices, and we are asked to simplify the following. So you can see numbers to certain powers. So obviously, you should know that we are dealing with what? Indices. Okay, so solution. Okay, as always, okay, once the questions are numbered, our solution must be numbered. So we are looking at solution to question 1A. And question 1A, what are we giving? We always extract. We are giving 2 to the power 15 times what? 2 to the power what? 7. Okay, so we know there's an expression we start with equal to. And okay, you know, at first, I used to tell you that your equal to here shouldn't even come close to, what do you call it, the giving. It shouldn't be under the giving. Was that not what I told you?
Yes, please.
Very good. Okay, however, you can see that I have violated that. Okay, and it's intentional. Now the situation has changed, and the situation has changed. Okay, meaning we are relaxing some of these rules because you are in elective math, and now even in core math, I don't know of what will happen in the core math for our section of the world, I mean Ghana. But Nigeria, the core math 1-2, they were given a constraint paper. So they were provided a space to provide a solution there. Unlike the usual one that the question will come and you'll be given an answer booklet where you are free to write. Here, if they write the question, then they will provide space there for you. So if you waste the space, you know what will happen. It's my point well made. So because of that, this is what we encourage them to do. Anytime you are writing, you push your presentation here. So you start writing close to the margin. And when you start writing close to the margin, you always push your presentation here. Then there will always be room here. So in case it doesn't go there, you can rule a line there, then come and continue here. But however, if you push it here and you finish solving, no matter how big this space is, you can't come and do, okay, any other work, okay, here, because we work in this direction. We don't work in this direction. It's my point well made.
Yes, please.
So my point is now, anytime you are writing, if you are moving from one line to the other line, you start writing close to the margin. So start from the margin, like you always do anytime you are writing. Start from the margin, period. Okay, so assuming my margin is here, so I'm starting from the margin. So this will be equal to, okay, I have the same base multiplying, so I keep my common base. When they are multiplying, what do? I have to add the exponent. So that will give me 15 plus 7. So 15 plus 7. And as you mature, please take note. This 15 plus 7, you can do it mentally. So I can move from here to my last result that I'm going to write. So that will give me 2. 15 plus 7 will give us what? 22. Am I right?
Yes, please.
So you get 2 to the power 22. So don't forget your conclusion. Therefore, okay, now, okay, I'm writing close to the margin. So therefore, my 2 to the power 15 times 2 to the power 7 will be equal to what? 2 to the power 22. As simple as that. Hey, now what happened? You're also enjoying your sleep.
Please, all of us slept.
Hey, so you're enjoying your sleep.
Please, I'm sorry.
Matthew, why? All right. Okay. So your sorry will be accepted in our next meeting if you are not late. However, if you are late, I will accept your sorry.
Yes, please.
Okay, all right. So take note. This time around, okay, because we are few, I want us to cover. Is that clear? Okay, it's
Yes.
intentional. So let us cover. And if you will cover, then it means you have to come late. I mean early. You don't have to come late at all. And
Yeah.
it's even likely, usually you can see that in our next meeting, we will have to come and discuss the assignment. Okay, so what I intend doing is I will do the video of the discussion of the assignment in your absence, send it to you. Okay, when you come and there are other issues, then we deal with it, then we move. Because sometimes the discussion can take even our first session, which wastes our time, especially those who got everything right.
Yes, please.
Okay, so that's what I intend doing. Okay, now I'm a little free, okay, in terms of teaching. Okay, but I'm a student too, so I have to learn. So I'll try as much as possible to do that. So now this is what we have. So B, okay, what do we have? We have 5, giving 5 to what power 7, okay, divided by, okay, 5 to the power 5. So we know whenever we are dividing, once the bases are the same, we keep our common base. Then this becomes my numerator exponent, my denominator exponent. So I subtract the denominator exponent from the numerator exponent. So that gives me 5 squared. Is my point well made?
Yes, please.
Yes,
Okay,
please.
so this then becomes therefore your 5 to the power 7 divided by 5 to the power 5 is equal to what? 5 was squared. Okay, as simple as that. I have told you the first set of examples basically is to whet our appetite. The next one, then I will be adding, okay, a little more bone. So C, okay, what are we giving? We've been giving 5 to the power 7 over, okay, 5 to the power 9. So we are dealing with division, only that this time around, we didn't use the division symbol. Yeah, we've used the division by a third division. Okay, so we are supposed to use the quotient rule. So this will give us what? You keep your common base, then it will be your numerator power minus your denominator power. So that gives us 5. 7 minus 9 will give us minus 2. Am I right?
Yes, please.
Okay, but remember, I told you that we avoid concluding with what? A negative exponent. So unless maybe the question specifically asks you to do so. Otherwise, please don't. Okay, so in this case, we are going to write it as 1 over 5 whole squared. Is my point well made?
Yes, please.
Yes,
Okay,
please.
you draw your conclusion. Therefore, 5 to the power 7 over 5 to the power 9 will be equal to 1 over 5 whole squared. As simple as that. Any questions at this point? Okay, we thank God you are all fine. So now, quickly, let's move on to D. D, what are we giving? We are giving 6 to the power 7, okay, times 6, okay, to the power 12 times 6 to the power 9, all over, okay, 6 to the power 8 times, okay, 6 to the power 10, then times 6 to the power 22. Okay, so this is the best approach. This will be equal to, we are going to work on the numerator and the denominator separately. Okay, so I take my numerator, I'm going to get, okay, 6. I can see multiplication in all of them and they all have the same base. So I have to keep my common base, 6. And this time around, okay, all of them multiplying. I have 3, okay, powers or indices. So what do? I need to add these 3, okay, by extension. You know that if it is 2, you add the 2. When they are multiplied, if it is 3 by extension, you have to add the 3 powers. Am I clear? So I'm going to write this as 7 plus 12 plus 9. Okay, then all over 6, this one to be a multiplying. So I'll get 8 plus 10 plus 22. And this step that I have here, like I said, is basically for explanation purposes. You can always do it mentally. So meaning you can move from here to what I'm now going to write, and you won't lose any math. So this will be equal to, okay, you keep your base. Now we are adding. So this plus this will give us 19. Is that not it? 19 plus 8 will give us what? 28. Am
Yes,
I right?
please.
Okay, so 28. Then over your 6, now you are adding this. This plus this will give you, okay, 30. So I'm going to get 40. Am I right?
Yes, please.
Yes,
Okay,
please.
good. So and now you have one base, another base, but they are divided the same base. So you keep your common base, and now because of division quotient, you will subtract the denominator exponent from the numerator exponent. So you are going to get 28 minus 40, which gives us 6. And again, this one you can skip and do it mentally as you mature. So 28 minus 40 will give us minus 12. Minus 12. Okay. But can I conclude here?
No, please.
No, please.
So I avoid concluding with the negative exponent. So I use the negative
No.
power, which will give you 1 over the positive power, which is what? 12. So you draw your conclusion. Therefore, okay, 6 to the power 7 times 6 to the power 12 times 6 to the power 9 all over your 6 to the power 8 times 6 to the power 10 times 6 to the power 22 will be equal to what? 1 over 2 to the power 12. Hope I'm clear enough.
Yes, please.
Okay, and now to the last one, E. Okay, E, what are we giving? We are giving A squared all cubed, okay, times A cubed all squared. Okay, so here, obviously, you can see powers. So it means we are supposed to rely on what? On the power rule. Okay, and by the power rule, okay, any number to a certain power raised to a power again, we multiply the exponent. So this will give us a to the power 6. Then times, okay, you keep your common base and add the exponent, so you get a to the power 6 as well. So now you have a base, common base multiplying. So a, you add the exponent, so it will be 6 plus 6, which is what? 12. So now I'm assuming these mature. So that's the more reason why I skipped the step. Okay, that's okay. I said you can do it mentally, the addition of the exponent step. Is that clear?
Yes.
So what do? We comfortably come and draw our conclusion. Therefore, a squared cubed times a cubed squared is equal to what? A to the power of 12. As simple as that. Okay, any questions at this point before we go and look at our second set of questions? Hey, Nancy, are you here?
Mr. Hackman,
Yes, please.
please, I can't see the board though.
Oh, really? Who else can see the board? Okay, who can see the board clearly?
It's me.
Okay, then it means Rosemary is coming from your end. So you have to disconnect and reconnect. However, we are all going to disconnect because I think we have some few minutes for us to be automatically disconnected. So we'll do that, then we all come back and look at our second set of questions. Is that clear? So let's all disconnect and come back ASAP as soon as possible.